Hello, and welcome back to the final speedrun of today with me, Vince. And so in this speedrun, we're going to be going through the mean, median, and mode of a continuous probability distribution function. So let's jump right in. So the mode is the value of x that has the greatest probability, and so it's the maximum of the probability density function. So we can find it. We just need to find when f prime x is equal to 0, and of course f double prime is equal to a positive number. A negative number. So therefore it's a maximum. Yeah. That's the mode. So the median is referred to as the midpoint of the frequency distribution, and so there's an equal probability of a value being higher than the median or lower than the median, since it's in the middle. And so therefore, we have the probability that a number is lower than the median of f of x dx must be equal to 0.5. And likewise, the probability that a number will be greater than the median is equal to 0.5 as well. So the mean for group data is... Okay, so for the mean for group data of a continuous variable, we can split the range of the variable into infinitely small steps. So like, stuff like that. And so we have the center of each strip. And if we replace the frequency with the probability, therefore, the more or less what we get is that the mean of a continuous variable, a random variable, is of course the expectation, is equal to the limit from negative infinity to infinity of x times f of x dx. Yeah. So that's pretty good. And so of course the expectation squared would be x squared. Okay. With that being said, we can now jump into some problems. So the first problem is Okay, so first, sketch so the following function is given. So first, sketch the graph. Next, explain why functions of this type are probability density functions. Next, find the probability that 1 is less than x is less than 20. And finally, find the mean, median, mode, and standard deviation. So what we have is we have defined as f of x is equal to 1/8 of x for the interval of 0 is less than or equal to x is less than or equal to 4. And of course, 0 elsewhere. So first, sketch the graph of this function between 0 and 4, 1/8 x looks like that, and then it will jump back to 0. That's pretty much it. Wait, is this 1/8 or negative 1/8? What are they talking about? Oh yeah, it's 1/8. Okay. So it looks something like that. Explain why functions of this type are probability density functions. Well, it's because the limit between negative infinity and infinity of this function, 1/8 x, is equal to 1. I mean, not 1/8 x, but actually the bounds. So it's only the limit between 0 and 4 of 1/8 x will be equal to 1. And so therefore it's a probability density function, and also it's also non-negative for all possible values. Next, find the probability that 1 will be less than x, will be less than 20. We don't have to consider 20. We only have to consider until 4, since it's 0 past 4. So we have the limit between 1 and 4 of 1/8 x dx, which is equal to 1 and 4 of 1 over 16 x squared. So this is equal to 1 minus 16 over 16 minus 1 over 16. So this is equal to 15 over 16. So it's 15 over 16 chance it will be in that interval. Finally, find the mean, median, mode, and standard deviation. Okay, let's start with the mode because that one's the easiest. The mode is 4. And that's because 4 has the highest probability density. Since the graph looks like this, we're just looking for the highest point on the graph, really, and that's the mode. And so it's this part. So mode 4. Next, median is probably the easiest. So we have the limit between 0 and the median. It should be negative infinity, but it's not defined. Well, it's just 0 past that. Of 1/8 x dx is equal to 0.5. So in other words, 1 over 16 times the median squared must be equal to 0.5. So the median squared must be equal to 0.5 times 16, 8. So the median must be equal to 2 square root 2. So median is 2 square root 2. And then finally we get to the mean. And so the mean will be equal to the mean will be equal to the limit between 0 and 4 of x times 1/8 x. So this is 1/8 x squared dx. And so this will be equal to 4 and 0 of 1 over 16, no, 1 over 24 x cubed, which is equal to 64 over 24, 32 over 12, which is 16 over 6, which is 8 over 3, 8 thirds. Yeah, it's just 8 thirds. So the mean is equal to 8 thirds. And so to find a standard deviation, we need to integrate 1/8 x cubed to find the, We need to integrate 1/8 x cubed to find the mean of the squares, and then we subtract the square of the mean from it. So this is equal to 1 over 32 x to the 4, between 4 and 0. So this is 4 to the 4 over 32, which is equal to 8. So we have 8 minus 8 over 3 squared, which is equal to the variance. Do we need to find standard deviation or variance? We need to find standard deviation. So this is the square root of all of that. So the square root of 8, square root of 72 minus 64 over 9. It's equal to, this is just 8 over 9. It's just 8 over 9. So this is equal to 2 square root 2 over 3. Nice. Okay. And then on to the next one. We have a continuous. Random variable x has probability distribution function given by, I'll write it out. So first find the probability that pi over 12 is less than x is less than pi over 6. And then next find the values of the median, mean, and mode. And the function is f of x is equal to 2 cosine x, 2 cosine 2x, where 0 is less than x is less than 4, and of course pi over 4, and of course 0 otherwise. So the probability that it's in between these two is simply the integral between those 2 points. So we have pi over 6, just check it's defined, yeah, and pi over 12 of 2 cosine 2x, which is of course equal to the integral between pi over 6 and pi over 12 of sine 2x, which is equal to sine pi over 3 minus sine pi over 6. sorry, sine pi over 3 minus, yeah, no, just sine pi over 3 minus sine pi over 6. So this is equal to root 3 minus 1 over 2 is that probability. So that's cool. And then now we need to find the mean, median, and mode. So mode is the easiest one. The mode will be when when cosine 2x is equal to 1. So x is equal to pi over 8 will be the mode. No, pi over 4. No, pi over wait. Because we need pi over 2. Yeah, so pi over 4 will really be the mode. So the mode is pi over 4, since it's just the largest value. Oh wait, no, cosine, please, what am I doing? The mode will be at 0. Since this is a cosine function actually, it's just because the derivative was a sine function. The median will be when between 0 and m of, we've already integrated it, so it's just sine 2x is equal to 0.5. So we have sine 2m is equal to 0.5. So 2m is equal to pi over 6. M is equal to pi over 12. So the median is at pi over 12. And then the mean is the integral between so 0 and pi over 4 of 2x cosine 2x, which is probably the hardest one, since this requires us to use integration by parts. So this will be equal to u is equal to 2x, u prime is equal to 2, v prime is equal to cosine 2x, v is equal to 1/2 sine 2x. So we have 2x sine x between 0 and pi over 4 minus the integral of 2 sine x. Sorry, this should be 2 sine 2x, which is equal to plus cosine x. It's cosine 2x. So we have plus cosine 2x. And this should only be x sine x, since this is 2x times 1/2, yeah. So we have the mean as equal to x sine 2x. So sine pi over 2 is equal to 1, so pi over 4, plus cosine 2 times pi over 4, which is pi over 2, so it's 0, minus cosine 2x, so minus 1. Cosine 2 times 0. It's 1, isn't it? Or wait, do I have to multiply 1/2 to this? Oh, I do have to multiply 1/2 to this part, sorry. Because the integral of 1/2 sine x of sine 2x is equal to 1/2 sine 2x. So this is minus 1 over 2. So this is equal to 1/4 times pi minus 2 is the mean. Yeah, cool. Okay, and so on to the last question. And the last question is a continuous variable x has PDF of, I'll write it out. So first find, in terms of A, the value of B. Next, given the median is 1, determine A and B. And finally, find the values of e to the x and var, the variance of x. And the distribution function is equal to ax squared plus b for when 0 is less than x is less than 3. So find in terms of a the value of b. So the integral between 3 and 0 of ax squared plus b must equal 1. So this is between 3 and 0 of 1/3 ax cubed plus bx is equal to 1. So 9a plus 3b is equal to 1. So find in terms of a the value of b. So b is equal to 1/3 minus 3a. So next, given that the median is 1, determine a and b. If the median is 1, that means that the integral between 0 and 1 of ax squared plus b must be equal to 0.5. So we have 1/0 of 1/3 ax cubed plus bx is equal to 0.5. So we have 1/3 a plus b is equal to 0.5. Since we know b is equal to 1/3 minus 3a, we actually have 1/3 a minus 1/3 plus 3a, plus 1/3 minus 3a is equal to 1/2. So we have negative 8/3 a is equal to 1/2 minus 1/3. So that's equal to 1/6. So we have negative 8a is equal to 1/2. So a is equal to negative 1/16, it appears. And so we know b is equal to 1/3 minus 3a. So that's equal to 1/3 minus 3 plus 3/16, which is equal to 25/48. Okay, finally find expectation of x and variance of x. So we know the function is equal to negative 1/16 x squared plus 25/48. So first to find the mean, which is the expectation, and remember this is defined between 0 and 3. We need to get the integral between 3 and 0 of negative 1/16 x cubed plus 25/48 dx, which is equal to 3/0 of negative 1/64 x to the 4 plus 25/48/296 x squared. So this is equal to negative 81/64 plus 25 times 9, 225/96. So if we cross multiply, this is 81 times 96. So 225 times 64 minus 81 times 96. So this should be 6624 divided by 64 times 96, which is 6144. So these are both divisible by 4, so divide by 4. 1536 over 6624 divided by 4. 1656, and both still divisible by 4. So we have 414 over 1536 divided by 4. 384. These aren't divisible by 4, but they're divisible by 2 still. So it's 192 divided by 414 over 2 is 207. This both divisible by 3, so divided by 3 is 69/64. So the mean is 69/64. Now we need to find the variance, which we can find by integrating. By integrating between 0 and 3, negative 1/16 x to the 4 plus 25/48 x squared dx. So this is equal to between 3 and 0 of negative 1 over 80 x to the 5 plus 25 over what's 48 times 3, 144 x cubed. So this is equal to negative 343 over, 243, my bad. 243 over 80 plus 25 times 27, 675 over 144. So this is equal to 243 plus 144. Oh, sorry, wait. This should be 675 times 80 minus 243 times 144, which is equal to 19,008 over 80 times 144. 11,520. And so now we have to subtract the square of this. 69 over 64 squared, which is equal to so this is equal to 19,008 over 11520 minus 69 squared, 4761 over 64 squared, 4096. So I know these two have a common multiple of 64, so we just have to multiply this side by 64 and this side by 180, I think. So it's 19008 times 64 minus 4761 times 180, all over 11520 times 64. 19,008 times 64 minus 4761 times 180 divided by, so this is 359,532 divided by 11520 times 64 divided by 737,280. But it's hard when there's such big fractions. I can't tell if I've made a mistake. Negative 243. I just hope I haven't made a, wait, maybe I can simplify this. 19,008 is 520 divisible by 8. Yes, it is. So we can divide both of these by 8. This is 65. And 19,008 divided by 8 is 2376. Okay, so at least we have slightly less unreasonable fractions. So this is equal to 2376 divided by 65. Wait, 675, 80 times 144 divided by 8. Oh wait, this is only over 1440. Minus 69, 4761 divided by 4096. So what common factors do these two fractions have? That actually, so 1440 divided by 8, so it's divisible by 16. So this is 2 to the 4, 2 to the 5, times 5 times 9, And this is 2 to the 4096 divided by 16 divided by 16, 2 to the 12. So we need to go 2376 times 2 to the 7 minus 4761 times 5 times 9 divided by 1440. Oh no, wait, it's just 2 to the 12 times 5 times 9, which is equal to 2376 times 2 to the 7 minus 4761 times 5 times 9. So this is 89. Oh. Divided by 2 to the 12 times 5 times 9. So divided by 184, 320. So can we simplify this? Yes, they're both divisible by 3. So 89883 divided by... Are they both divisible by 9? I don't know. 29961 divided by 61440. 15. They are still both divisible by 3. So 2480. 9987. Yeah, these aren't divisible by 3 anymore. So yeah, I think this is the smallest that we can get it to. So this is the variance of this original function. Well, quite a long question. I hope you enjoyed, and I hope to see you in the next speedrun. See you then.